So we have to draw an arrow to show how we have to draw a graph to show how the momentum changes. Basically how the speed changes, not the momentum. So originally it was 4.5 and then it changes to 0 in the same time interval and it will remain 0. The next part of the question, calculate the force that each truck exerted on other. Because the change in momentum, whenever there's a collision, the change in momentum of object 1 will be same as change in momentum of object 2. So we can find the impulse of any object. So an impulse multiplied, we have force is equals to impulse divided by time. How we can find the impulse? Impulse is a change in momentum, so it is mv minus mu divided by time. So you can take any of the truck. For the first truck, it is convenient to find the force. Why? Because the final velocity is 0, so I don't have to calculate the momentum, final momentum. So it's initial momentum divided by time interval. What time interval I will take? The time interval which is responsible for change in the speed. So this time interval is given in the question. It's 0.1 of a second. So mv minus mu divided by time, we will know the impulse. Is it clear?
Yeah.
And the last part, the collision between the railway tracks is elastic. What is meant by elastic collision? So the term elastic collision refers to when the momentum and kinetic energy both are conserved. We call that as elastic collision. Then show that the total energy halfway through the collision is less than the total energy after the collision. So in total energy halfway during a collision is less than the total energy after the collision. So how you can identify the halfway during a collision? So this interval is 0.1 of a second. So halfway or a center point will be this. And we already did the first part, for which here the velocity was 4.5 and then it decreases to 0. And it remains 0. So what we'll do, the halfway or the midpoint during a collision. So we'll find the speed of object 1 and speed of object 2. We will use this speed, find kinetic energy of both objects. Kinetic energy is half mv square. So half mv square for object 1 and half mv square for object 2 before collision, and their final after collision half mv square only at the last or at the end. Final velocity of the 20,000 kilogram object is 0. 60,000 kilogram object will have its velocity. So you have to show this by a calculation. So half mv square, you will use the speeds and the masses, calculate the kinetic energy in half mv square, but the final kinetic energy of 20,000 kilogram object is 0. So energy is only due to 60,000 kilogram. And the calculation will show that both energies are not equal. Because you have to show that they are not equal. So definitely it will come out. Suggest a reason for this. What could be the reason? What could be the reason why the What could be the reason here? Why the kinetic energy before, like in between, is not same as the kinetic energy after? Can you identify it from the figure? Why the kinetic energy is halfway between the collision is not same as the kinetic energy at the last?
So there are
Energy
springs.
loss to railway.
Ener- but if the energy is lost, then why the final is higher?
Of fun.
The final and kinetic energy is higher, middle, halfway during a collision, the kinetic energy is small or
Oh,
less.
sir,
Yes.
there are springs, so some energy is stored in the springs.
Yeah, during a collision, actually energy stored in the spring. That's why during a collision, as the energy stored in the spring, the kinetic energy will decrease. But once the spring again, initially they compress, when they extend or return to their original positions, the energy will again transfer to the trucks, the railway trucks, so that the kinetic energy will increase. Is it clear?
Yes, sir.
Question 3, what could be the answer? Question 3. Select the row of the table that correctly identify what happened in an elastic collision.
A.
Yeah, that's correct. A is the right answer. The total energy is conserved always. The kinetic energy in elastic collisions, it is conserved. In elastic collision, not conserved. Momentum is conserved in both cases. Question 17, part A, state the principle of conservation of momentum. What is the principle of conservation of momentum? What it state?
Sir, sum of momentum before and sum of momentum after the collision should be equal.
Equal, but it's of 2 marks. You will get 1 mark for this statement. There is another point which you have to mention. What is that point? That point is in an isolated system, a system which does not experience or influenced by external force. So in an isolated system is 1 mark. Momentum before collision is equals to momentum after collision. State the relation between the resultant force acting on the object and the momentum of the object. How you relate momentum with resultant force? Or how you can relate change in momentum with resultant force? If you apply greater resultant force, then change in momentum will be small or less? Oh, sorry, small or large?
Large.
So greater change will occur. So so resultant force is directly proportional to change in the momentum. A car is traveling due east with a velocity of 12 meter per second. The driver of the car changes the direction to travel due north with a speed of 15 meter per second. The initial velocity is shown. Complete a vector diagram to find change in the velocity. Change in the velocity or the difference in velocity. A vector diagram. So how we will use a vector diagram to find the change in the velocity or difference in the velocity. So difference in velocity, it will be V2 minus V1. Okay. So a car is traveling due east. They give you, as we know, we have the compass, north is up, south is down, east is towards right, and west is towards left. So if we need a change in the velocity, means we need V2 minus V1. So we'll draw the second vector. What is the direction of the second vector? Is due north. So 12 meters per second. So we'll draw the second vector. Sorry, 15 meters per second. This is a vector addition rule. If I need a resultant according to vector addition rule, the vector addition rule, the resultant is always from tail of the first to the head of the last. So if I draw a resultant here, so it should be from tail of the first to the head of the last. So I will draw a resultant like this. But this resultant is not correct. Why this resultant is not correct? This resultant is V1 plus V2. This is V1, velocity 1. This is velocity 2. So this resultant is V1 plus V2. But in the question, we need a change in the velocity. We need V2 minus V1. So how I'll get V2 minus V1? Is it clear? This point till this point? The idea of the vector addition rule, because in vector addition rule, the resultant is always from tail of the first to the head of the last. So if we need V2 minus V1 or change in velocity, so what we have to do, basically it means that V2 added to minus V1, and that will give us the change in velocity. So if this is V1, what will be minus V1? The minus V1 will be in opposite direction. I'm drawing it separately to explain the idea, and then, so this will be minus V1. Then I will complete the figure as well. And then we draw V2. We start the second vector from the head of the first vector. So this is V2, which is 15. And then from tail of the first to the head of the last, when I join, this will be the result of V2 minus V1 or the resultant vector. Is it clear? Because in the question, we need a change in the velocity. When we need change in velocity, we need V2 minus V1 or difference in the velocity. So when we complete this vector diagram, we don't have to show the arrow here, but basically it's opposite. And then we draw the second vector, which is V2. And the resultant vector is from tail of the first to the head of the last. So actually this will be the tail and this will be head of the last. So this is the resultant of V2 minus V1. If in the question they ask calculate the sum of the result or calculate the resultant velocity V1 plus V2, not the change. They ask for resultant. So then in that case, how I will find the resultant? If I need V2 plus V or V1 plus V2, so V1 is already there. I will draw V2 from head of V1 and from tail of the first to the head of the last, we will get the resultant. Okay, so this is resultant, which is V1 plus V2. But in the question, they don't ask for V1 plus V2. They ask for change in the velocity, and change in velocity is final minus initial. So vector diagram, you will find question related to vector diagrams. So you have to recall this concept of vector diagram to solve questions. And then we have to determine the change in the velocity and the direction. So how we can determine change in velocity? You have to select a scale. How we get the scale from this? So using a ruler, you will measure the length of this 12 meter per second. An example, if this 12 meter per second example, according to paper size, it was 6 centimeter. So you will have the scale that 6 centimeter is equals to 12 meter per second. Then 15 meter per second will be x centimeter. So you can have, or you can identify what length should be there. And angle is a direction of change in velocity. So when you draw this vector and you got the resultant, this was the resultant. So the term direction means this angle. So you can mention 30 degrees from 12 meter per second, or you can also use the compass here, north, south, east, and west. And you can mention or measure the angle from west and mention 30 degrees from west or 40 degrees from west. Then we need a force. We have the change in velocity. You will have the change in velocity here, and you have 4 seconds. So change in velocity divided by time, you will get acceleration, and acceleration F is equals to ma. So mass multiplied by acceleration, you will get the resultant force in newtons. Is it clear?
Yeah.
What's the answer for question 7? The electron has a momentum of 1.9 exponent minus 24 kilogram meter per second. The kinetic energy of electron is question 7. What could be the answer? You have to calculate. You have the momentum, you need kinetic energy. There's a formula which relates kinetic energy with momentum.
Sir, what is the mass of the electron?
Mass of electron is 9.11 into 10 to the power minus 31 kilogram. That in exam it will, you can see the last part of the constants. Here. So mass of electron is given 9.11 into 10 to the power minus 31.
Answer is B.
Here B is the correct answer. In a bowling game, a player rolls a small ball along the ground. The diagram shows the action of a player as he starts to swing his arm forward at A to a point when the ball is rolling along the ground at C. The player exerts a force on the ball between A and B. State how the motion of the ball at C differ from that of at B. Like state how the motion of the ball at C differs from that at B. So what is the difference in the motion between B and C? Can you identify from the figure? Yes, it's a general answer. There's no specific, Like it's your understanding from the figure you can mention.
So there will be some deceleration at C because of friction.
That's correct. And what about B? So B, there is no deceleration. At B, it is accelerating. At C, it is decelerating. Yeah, or it will decelerate. Why it will decelerate? Because there's a frictional force. So 2 marks. One is at B, the ball is accelerating and its speed will increase. The second mark is at C, the ball will slow down due to the friction. So there was no fixed answer, like it was journal question rather than from a specific topic. The player applies a forward force of 0.2 seconds. The ball leaves the player hand at a speed of 3 meters per second. Calculate the average forward force that the player applies to the ball. The mass of the ball is 1.5. So what is the force? What's the answer for the force? The change, you can use the concept of change in momentum divided by time. What's the force?
So 22.5.
22.5. So basically you use the change in momentum or you can find acceleration and then, but in exam it's better you use change in momentum formula because you are studying that concept. So you will, when you mention the formula, better mention change in momentum divided by time rather than mentioning F is equals to M. These formulas are the same, but a slight difference like representation is there for momentum. This question, the ball rolls along the ground until it collides with a stationary ball of mass 1.2 kilogram. After the collision, both balls roll off at an angle to the original. You're looking this from the top. So after collision, 1.5 kilogram ball travel at 0.7 meter per second and 1.2 kilogram ball travel at 1.8 meter per second at an angle of 20. Show that the velocity of the first ball as it collides with the second ball is about 2 meter per second. So you can see here what you will use conservation of momentum. It is about 2 dimension because the momentum will have component horizontal and vertical. So this velocity after collision will have 2 components. This will be V2 cos 20 and against the angle, I'm drawing a bit away from it. So to distinguish, this will be V2 sin 20. And this one, it's also along the or in the angle. So this will be V1 cos 45 and this will be V1 sin 45. So to solve this, what I will use, I can use the conservation of momentum in x direction. So we have the formula m1 u1 plus m2 u2. In x direction, I'm taking is equals to m1 v1 plus m2 v2. Initially, the object mass 1 is there, 1.5 kilogram, multiplied by velocity at which it is moving is v. The second object was stationary. So what is the initial velocity? It was 0. So this whole momentum will be 0. I'm not writing the mass here. M1 is 1.5. Now what velocity I will take for V1? So I will take V1 cos 45 degrees plus the second one, the mass is 1.2 and we'll get V2 cos 20 degrees. And V1 and V2 is already given. So V1 is given 0.7 and V2 is given 1.8. So instead of V1, you'll substitute 0.7, and instead of V2, you'll substitute 1.8. Can you solve what is the final answer for the velocity?
Final answer 1.85.
Yes, that's correct, 1.85. So the final answer, when you solve, the speed is 1.85. By mean of a suitable calculation, show that the collision is inelastic. So if you want to show collision is inelastic, the momentum before collision, the kinetic energy before collision is not same as kinetic energy after collision. But when you are using the kinetic energy, you don't have to bother about the angles. Why you don't have to bother about the angles? Because energy is a scalar quantity, so direction does not affect its magnitude. Or direction does not have any significance to it. So what you can do, you can find the kinetic energy here. This was 1.8. So kinetic energy is half mv squared. This is kinetic energy 0. And kinetic energy after collision, you will use half mv square. And this one is also half m1 v1 square. So you will get the kinetic energy of each, add them. That will be the final kinetic energy, and add these two. This one is already 0, so you don't have to add. Just the kinetic energy of ball 1 is same as the kinetic energy before collision. And when you compare the kinetic energy before and after, so you will find a difference between them, which shows that the energy is not conserved. Is it clear now?
Yeah.
Question 9. What could be the answer? January 2017, question 9. A ball of mass m with a velocity v strike a wall perpendicular, bounce off with the same speed in opposite direction. The collision takes time t. Which of the following is the mean force that acting on the ball during a collision? Yes, correct. D is the right answer. How you will solve this question? Because the ball is moving perpendicular towards the wall with velocity v, and the ball bounce back with the same speed, but velocity is a vector quantity. So if one you are taking positive, the other one should be negative. So what is the momentum before collision? It's mv. What is the momentum after collision? It's minus mv. And what is, you need a force. Force is the change in momentum divided by time. So change in momentum, the final is minus mv, and the initial is, this negative is for the formula, the change. The final momentum is minus mv, initial momentum is mv divided by time t. So minus mv divided by t. So it will be minus 2 mv divided by t. So D is the correct answer. Is it clear?
Yeah.
The wavelength associated with a moving particle known as a de Broglie's wavelength depend on the momentum of the particle. Show that the momentum and kinetic energy are related by equation Ek is equals to P square over 2m. So it's the same thing, like you have the momentum is a product of mass and velocity, and kinetic energy is, or Ek, is equals to half mv square. If I multiply kinetic energy formula by mass, so it will be m square v square over m. And if I take this square for both, then it will be half m and v square. That's it. That's of 2 marks. In question 18, a student read the following extract from a textbook. In an inelastic collision between the object of equal mass, where one is initially stationary and the object move of 90 after collision, the student investigate using a collision between identical steel ball, each of mass 66 grams. The diagram illustrates the collision between the balls. So a stationary ball collide, a moving ball collide with a stationary ball. And if the collision is elastic collision, the angle should be 90 between them. In one experiment, U1 was 0.72 and theta was 29. For such collision, it can be shown are separated by angle theta 90 degree, then V1 is given, phi is also given, and V2. Show that these values justify the condition for conservation of momentum in initial direction of ball 1, means conservation of momentum in x. We have all the values. What we have to substitute, the mass is in gram, so we will convert into kilogram, SI unit. And in initial direction, so we'll take a conservation of momentum in x. So we will resolve this into two components. The one which is with an angle, so this will be V2 cos phi, and this will be V1 cos theta. And against the angle, this will be V1 sin theta, and this will be V2 sin phi. So the two values are, all the values are given, the mass is there, the final velocities are there. Simply you have to substitute and show that the momentum before is equals to momentum after collision. Is it clear?
Yeah.
So these are some questions related. Other parts are also related to momentum, but similar parts as we discussed earlier. So next class, I will start a new topic, which is about circular motion. And then the same way we'll do, I will explain circular motion, and we'll do some questions related to the circular motion from past paper for a better understanding. So I'll share the recording and end the session now.